go straight up. I just wanted to highlight a couple of things. One, whenever we get work on tools and code, I know I tend to get sort of wrapped up in that, and I always want to bring the focus back to these kids who are having an absolute ball. So you can see those kids absolutely love it and they're learning tons. And the other thing I want to highlight is I really focused on text-based coding because that's what we have to do in year 11 and 12. And you can see there, kids are writing text-based code, object-oriented, event-driven text-based code in year 10, in year 9, in year 7. And that last one in year 6, a friend of mine, that's his son, so I'm doing personal tutoring with him. But it displays that even a child as young as that in year 6 can write text-based object-oriented code with functions and all the other fun stuff that goes with it. So the title of today's talk is Digital Workshop, hopefully we'll get to that. Digital Solutions, Tools, Code and Community. I'm going to talk a lot about the tools and code. But something that's really important to me is community, both community amongst the kids and community amongst the teachers, which hopefully after today you guys will want to be part of that community as well. If you've got any questions, I get it coming up live here at that URL. So if your questions come up, I haven't actually tried this before, but hopefully the questions will come up and at an appropriate time we'll be able to answer those questions. We've got such a short amount of time. So before I get into the other stuff, I just really want to thank the people that have come. It absolutely blew me away. I thought there was going to be 3 or 4 of us from the Gold Coast and that'd probably be late. Turns out a whole bunch of people came, from all over the place. Bow Desert, what have we got? Ipswich, Gatton. There's people from everywhere, and that makes me feel awesome. It makes me do a really good presentation. I went, wow, this is serious. I'm going to have to make this worth these guys' time. So thank you for coming and thank you for your dedication. You're exactly the type of people that hopefully we can form a community with. So thanks for that. Little note, that's an actual photo of the Ipswich people coming down the road. We had to take it late last night, so that long to get down. So anyway, so I know what you're thinking. You're thinking, who's this handsome young man standing before me? I would like to just go to this slide and say I'm the IPT Digital Solutions teacher at Varsity College and move on, because this is normally the least important part of the talk that you're not really interested in, but it does have some relevance to the tools that we're talking about. So just to give you a really quick background. So I've got a background in coding. I've worked in industry. I've written commercial code in probably, at least 12 languages. C, C++, Perl. I've done web. I've done mobile. I wrote a mobile framework, desktop development. So I've done a fair bit of that. And unfortunately, if you can actually talk to people and you're in industry, they keep pushing you into management. So I ended up not writing code and being a CTO as well for a software development company for a short period of time. Prior to that, I worked at university. I lectured in computer science for 5 years, and I taught everything from people who have never written a line of code in their life, and they turn up, some of them mature students, some straight out of school that didn't do IPT, so the absolute beginning, and right through to the other end. So in the middle, I was the course convener, author, and lecturer of data structure and algorithms, which was C++, and then later on just straight C, and we did really cool low-level stuff like, here's a chunk of memory, you're not allowed to create variables, you just have to pick a number of bytes out of that and use that to keep track of it. And so we did some more advanced stuff, and then on the very end of that, I also worked with PhD students to put their algorithms on parallel computing, because I put together a high-performance computing cluster, so you have lots and lots of computers working on a problem. So we take their sequential code, and I show them how to parallelize it. So I've done everything from one end to the other, and I found myself in secondary, where I absolutely love it, and this is the best job I've ever had in my life. So this is fantastic being here. So the reason why that matters is because that was the background I came from, and I came to secondary education. I went, okay, about a little bit earlier than this time last year, I went, okay, we've got this digital solutions syllabus coming through. What are the tools? How am I going to approach this? Actual photo of me looking for the tools. Little fun facts there for you. So that's me a bit over a year and a half ago, looking for tools that fit my needs. And I had a few things in mind, and I had the syllabus document there, and I wanted to marry up the tools that I've used, right tool for the job. So again, I had that experience in uni. I want something that's easy to get kids coding on to begin with, but if you were doing systems programming, then you need to be in C. So, you know, I'm quite language agnostic. I just want the right tool. So you know what I found? Desolate Wasteland. I found absolutely nothing that fit my needs. Okay, not quite nothing. I found a Python and a Turtle, and they were good to get started, but that was only just to get started. Oh, you guys are really polite. No one would get yelled out. Liar! There's tons of tools. We use them. What about, and insert your favourite tool. What about Grok, Learning, Scratch, GameMaker, Godot, Arduino, I don't know, Unity? Pick your favourite tool, throw it in there. Well, in the next couple of slides, just before I get into the tools I wrote, so you can see the motivation and what benefit the tools I wrote bring, I'll explain why some of these won't really do the job. Now, there's obvious ones. I'm not criticising these tools. These tools are amazing. They do some great things. Okay, so please don't think I'm criticising any of these. Scratch, for instance, great, fantastic for primary school kids, year 7 maybe. After that, we want to get to text-based coding, so obviously that's not a tool we use. Other programs have different issues as well. I love Arduino, but jumping straight to a C-based language from nothing, we get caught up in details we don't need to. So as somebody from university and from industry, the things I value is that algorithmic thinking, higher order thinking skills, not is it an int or a string. So I tend not to go for that sort of thing. But there's lots of reasons why they didn't fit my needs. So I thought, very begrudgingly, after trying hundreds of tools and really, really wanting to find them and not make them, because I've written enough code in my life, I begrudgingly went, no, I'm going to have to write the tools. I'm a software developer, I have the capability of doing this, I'm going to do it, and at least then it'll be exactly what I want. And I know from experience, most projects fail in software unless you have a really good foundation of where you're going and what your target is. So I went, well, what are my requirements? And I sat there for a few days and I figured out what my requirements are. And above all else, I kept coming back to, sorry about the coughing, must put the student learning above all else. Now, okay, so that might seem like an obvious thing, and I bet all those projects beforehand, or maybe not all of them, but some of them would have said, yes, we put students first above all else. Okay, I'm going to call them out on that because I don't think that's necessarily the case. I really mean above all else. So some people have said to me, hey, why don't you package this up and sell it? Well, I could, but that puts a barrier in. There's going to be kids that won't have access to this stuff. That doesn't put the kids first. And that's why I keep going back to that video at the start. That's my motivation. If I'm going to invest hours and hours and hours of code, I'm not going to compromise on this. Okay, so it has to be above kids. Now, you might immediately be thinking of an edge case of, well, what about this situation? Well, I've got a second rule. So there's two main rules, and then after that I go to other things. The second rule is, if a decision will in any way compromise student learning, see rule 1. Okay, so I can't emphasise that enough. And this made it really easy when I started making design decisions for writing the applications, because it was really obvious. I asked myself a couple of questions, and usually you get a fairly clear answer if you're honest with yourself, and it made it much easier for me to actually make decisions and progress and keep on there through all the bugs and through all the hours of coding. So what are my design decisions for these tools that you don't even know what I'm talking about yet, but we'll get there. So my design decisions based on this is it had to have minimal to zero network needed for these tools. Okay, there's a lot of web tools, and I can understand there's a lot of reasons why people promote web tools and the rest of it. I've found that that could be an issue. So when we were at university, Pete was involved with this as well, we had this environment that one of the lecturers wrote called the Java Programming Laboratory. It was used in a couple of schools, but it was used heavily in the university, and it was used for self-paced learning, short feedback loops, so when they write the code they immediately get a feedback of what's wrong, where it could be. They could access videos on a topic that they could watch over and over, and they could do it in their own time. And there was tons of reporting in there, so every time they clicked on something, every time they wrote a line of code, we knew about it, we had the statistics. If somebody wrote a line of code at 2 o'clock in the morning and they compiled it and it failed, it would come up in our stats, and we knew when students were working, when they weren't, and we could work around that, so we could use the classroom time more efficiently. Rather than they're doing this type of work there, we might work more of the theoretical and send them home to do it, or whatever it is. We worked around the data, and that was fantastic. Failed miserably in the schools, unfortunately. And we found out that it was heavily network reliant. Every time you did something, it talked to the network. And I don't know about you guys, but I can't afford to miss a class because there's something wrong with the network or someone can't connect to the wireless. And then I'm over there helping them connect to the wireless. No, it must just work. And I can hand you a USB stick, you can install this stuff on the machine, they can get running and they can be use it. And if they forgot their laptop, here's another machine that's on there. I can hand it to you on a USB stick, we're going. So that was one of the design decisions. Second design decision is it absolutely had to be open source. Why? Because it empowers teachers and empowers students. If you were on, say, Grok Learning, and again, not hassling the tool, it can be a great tool, and I've even used it myself, and you go on there and you go, okay, I like this series of lessons, but wouldn't it be really cool if we swapped this around or if we included this other thing? So what do? We either do nothing or you go to Grok, cap in hand, and say, can we please implement this? And they might not. And if they do, it might be a year from now. You have the power. Anything you want that I give you, you can change it on the spot and have it ready to go for the next lesson. Okay, and I've designed a lot of things. When we get to the SQL software, you guys can actually change up the questions. I designed it so you don't have to be a programmer to do that as well. You can write questions, you can put it in. We're going to be writing a tool to make that super simple. At the moment, you have to open it up with another tool and use it. And it empowers students. So I'm going to talk about GameFrame in a minute. It's a framework built on top of Pygame. And I didn't for a second think that students would be editing my code, but I made it there available. I didn't hide it away or put it in a library. It's there in their project, and they know about it. And I say, you don't have to touch this, but a few kids do, and they've done some really cool stuff. One of them, in year 10, actually contributed to the project. And if you look on my Git, there's actually a pull request from a student, and I've included his code because it's helpful, and it's now part of the project. So I never ever want to be the block. I never want to stop kids going beyond. I never hide anything. They get it all. So for all that to happen, it must be open source. Again, I'm not hassling anyone who has software that's not open source. I'm not a zealot, but for me, it had to be. And I put a real community there, but I should probably say a complete community. So there's a couple of different levels of community. One's like a user community. So we all get together and we're using this software and we help each other out using it. I've used this feature. Do you know how to click on that to get that? That's wonderful. That's a great community. That's one level of community. Next level of community might be the people who have the ability or have the coding ability to change things, might want to add features and contribute them back. And we can work together to improve the actual tools themselves. And the third type of community, the one I really hope for my tools as we go forward, is they'll be completely independent of me, that they'll be driven by the group of people. What do we really need? Maybe 90% of you think this would be really cool and I don't think it's really cool. You guys get it. So it would be driven by what the community needs rather than what my business interest is or what I'm just scratching my own itch or whatever it is. That's what I'm hoping for. And available. Remove all barriers to participation. Never impose barriers. So if you have to only access this site and the school blocks it, or if you're running a Mac and you're not running Windows, that's a problem. If you're running Linux or whatever it is, all my tools are completely cross-platform and accessible. So every single one of them can run on all three platforms, all three major platforms. So that was the design decision. Okay, you're going, all right, hurry up, let's get to the actual tools. Those of you who are old enough, not me obviously, I don't know who this guy is, but for those of you who might remember Mr. Squiggle, he says hurry up. Okay, so let's hurry up. So what's the plan? Now I said I didn't write absolutely everything. The first one and the last one are not mine, but I've written a bunch of coursework around it and tutorials, how-tos and all that sort of stuff. So basically what I have here is a progression from working with Python Turtle. And Python Turtle is just very, very basic, starting out, do basic commands. Anyone can do that, even primary school kids. So that's around, the way I work this is Turtle and GameFrame are around about year 9 start. GameFrame is the next step after Turtle. So Turtle will get us up to speed with basic syntax. It'll give us variables, it'll give us loops, it'll even, or on branching as well, it'll even go up to the level of functions. At that point, I start to find Turtle becomes a little less intuitive, not the perfect tool to go further from that. But that takes us a long way, and that's really, really good. A lot of people do go further with Turtle. At that point, cut and run. I think it's time to move on to another tool. So once they've got those fundamentals, we move on to GameFrame. So GameFrame is a Python framework that I wrote that sits on top of Pygame, and it's object-oriented, event-driven programming. So what that means is they don't have to worry about game loops, collision detection, any of that stuff. My framework takes care of that. What they do is they say, I have a room. Okay, what's the room going to look like? I'll set a background. Okay, now I'm going to have an object in the room. This is how I get to the object-oriented programming. In fact, I've got a set of slides if you want them that talks about the forms. You know, the old Greek philosophers talked about the forms and how something can be a knife but take on different types of knives and all that sort of stuff. So we talk about Plato's forms and we say, okay, you've got a room, let's put an object, put a player in it. So we've got a file called player. And it's got a location, so it's got an X and Y. And then we say, well, what happens if it collides with this other object? So we'll have a function that handles that. So it's all event driven, and they don't have to think about all the mechanics underneath. So it gets them going. So that's what you saw those kids playing at the beginning with. They were actually writing code in GameFrame. So that's sort of like year 9, so Turtle, GameFrame. Year 10's sort of a bit more GameFrame and Capture the Flag. So Capture the Flag is all about algorithms. So these all have a plan and they integrate in a particular way for a reason. Capture the Flag is they've got these little bots. When you walked in, you may have seen those little circles going around on the screen. So you program each one of those bots to work autonomously. One might be a jailbreaker, another one might be a defender, another might be an attacker to get the flag, and then you can set strategies. So at this stage, we understand basic coding, we've got objects, we can write functions, now it's all about the algorithms. And after that, these last two, these are your 11 and 12. Okay, so you guys might take a different direction with this, but you can take any part of this that you like and make use of it, or you can take the whole lot, it doesn't matter. So while I wanted this continuity and I wanted one to feed into the other and have this streamlined approach from 9 right through the end of year 12, if you find it useful just taking that slot out, then it's modular and you can do that. So My Query Tutor is an application that we wrote, I'll show you shortly, that teaches SQL. And what makes it different is it's local. As I said, I don't put restrictions on kids. If they want to learn about SQL injections and how to prevent them, then they can attack their own machine, that's fine. If I was running on a web server, I couldn't allow that. So it's all run locally, and they write SQL, and like that software we wrote in university, it gives that immediate feedback loop, so they can keep moving along. If any of you are interested, I co-authored a paper on JPL and that feedback loop when we're at university, so that talks about the advantages the student have when they get that immediate feedback. And PyQt5 and SQLite, so at this stage they're learning all their Python, they've got a nice good run up, they understand Python really well at this stage. We teach them all the SQL here, so they know about all their joins and selects and all the rest of it. And then we get down here and we say, okay, I'm going to write a desktop application. We're using Python, Qt is the widget set, and it's got a GUI builder, which I'll show you soon, which makes it really easy just to build the GUI, and you say, okay, when that button clicks, run this function. In a very similar way to the way GameFrame handles events. And SQLite, because it's easy, it's local. You can connect to it with 2 lines and it's going to be reliable. Comes back to that design decision of having little network usage as much as possible. So a lot of people, I think, we're going, okay, we have to have databases, maybe we have to connect to a MySQL or PostgreSQL database or something that's sitting on another server somewhere. That made me go, whoa, I've had bad experiences with that. So I checked, I spoke to Russell at QCAA, and he said that this was all good, it fell in all right, so I was quite happy with that. All right, so let's get on to the tools. Let's belt through this. Actually, I'm doing it the right time. Let's do these tools. So the first one I come up with when someone very first starts to learn to program is I use Turtle. And the great thing about this is I didn't have to write it. You just download it, you grab Python, you install it. What comes with it is this editor called idle. It all comes with Python. You just install Python, you've got this IDE, and you can run it by just pressing F5 or going run and run it. You've got this graphical environment here. And it's as simple as giving them import turtle, myTTL equals turtle.turtle. So I give them that bit of code, which just, I explain to them, brings in the code that we need to run, and then I create an object. Now, very first lesson, lesson 1, day 1, we've got variables, assignments, objects, function calls, and parameters, and that's what I call them, because one of the things I've really learned at uni is if you've got complicated concepts, introduce them early and repeat them often. So they start to use that language anyway. They don't really understand what a function is, but they know it's just an action that I'm calling. But you can see it's really easy. Call the object that you want, give it a command. So myTurtle is that little arrow. You can actually make it a turtle too. Give it a command like go forward 100 pixels or turn left by 90 degrees. Okay, now go make some shapes. Now, if I get a chance and there's time later, I'll show you some of this coursework. What I'm giving you guys today is a full 6-week program of how to step through that. So you've used it, Kylie, haven't you? And you're happy with it? Okay, so what's in that is I've got I've got worksheets, I've got answer sheets for teachers, I've got videos for students to watch as much as they want. I've got a few videos for teachers, if you're not familiar with it, to teach teachers how to teach that as well. I've got a final exam you can change or use it as a base. I'd like to have a few more of those. Of that community. Maybe we can all work together to improve this. Maybe you can fix some of the bugs. I did fix that bug, Carly, that you showed me the table. So that's all fixed in the documents. I'm going to share all that with you through, if you're in a public school, OneDrive. If you're a Catholic or private school, I'll give it to you through Google Drive, or you can grab it off this hard drive while you're here. So I've got that complete course there to give you. I'm not going to spend a lot of time on this. This is the real basics, and I've scaffolded it and given you everything. But just to show you a few things, they drew a square before, now we're going into looping, and I've got a whole video just for iron range, that they can watch that video. So we've now worked out, okay, we can do loops, and different questions require different scaffolding. With this one, I've provided all the code that detects a mouse click and gives you an X and Y coordinate, and it calls this function. So you can see your answer goes between here, I've got a question there in commenting, so their code is that. So we're learning the branching and the Boolean logic. We've got a whole lesson on Boolean logic as well. If, else, if, else, if, else, and depending on which quadrant they click in, it'll change the colour. I don't know why, but this is the turning point for kids. Every time, I've done like 4 cohorts, every time they get to this one, excitement goes through. You've got exactly the same experience, and I don't know why.
It's visualisation.
But you could give them all sorts of really other cool stuff, but because they've got this code and then they get this dot, they just absolutely love it, and they start screaming about how good this is. Then you get something really cool and they go, yeah. Still don't know why. But okay, so they love that bit. And at the end, this is the level we get up to. So this is like one of the last lessons. I give them this section up here, I import the turtle, I set the screen size, and I give them this code down here. You've got to implement a function called drawHouse. I'm going to tell you I want 100 pixels long, I want a red house and a black roof, or I want a blue house and a green roof, whatever it is, I give them this bit of code. So they've got to write that. In the exercise of the class before, they worked out through that evolution, we started by just drawing a square, one command after another, then we put it into a loop, and then we said, well, what if we want to draw a triangle? How do we figure out the angle? What if we want to draw a hexagon? And then we started figuring out, well, we can calculate these things. If you give me the number of sides and the side length and whether you want me to turn right or left when I'm drawing it, I can figure out the rest of my code. As long as all the sides are the same length and all the angles are the same, then I can divide it 360 by the number of sides, I can iterate and I can either turn left or turn right. And that's the level that they get to at the end of Python. That is a 5 to 6 week period. So not bad. So they've got through that. I found that to be really successful, and I've had that, again, I've taught 7, 8, 9, 10, even 12. I walked into a year 12 class that I asked them to write a loop, they couldn't. So we started from scratch. And in 1 year, we got through everything, and when I show you some of the games they wrote, it blew me away. So we can definitely do it in that amount of time. Okay, so turtles out of the way. Now we're on to the first of my tools. So game frame. So when I was looking at things to do, I've never been a gamer. I've never written games, never been interested in games, it's just not my thing. But kids seem to love them. So I thought, okay, well how can I get those happy smiley faces and learn how to do stuff? And I looked at a bunch of tools, and I had this problem where, and a lot of people may want to disagree or agree with me, I didn't see the translation from GUI tools like Scratch or GameMaker to text-based code. There seemed to be a gap in the middle. They get to a point with the text-based stuff, like GameMaker for instance, they could use the icons and be like, okay, write some GML. Okay, they go away, they come back, and they've done it with icons. Why'd you do it in icons? Oh, I tried and I couldn't do it, so I just went back to the icons. And so there's this real problem. So I wanted something that was like GameMaker, actually kind of modelled a bit off GameMaker, but without the option to fall back to using icons. So it's text only. So it's got a very similar layout, but the most important thing is it's text only, and I did it on top of Pygame. So why didn't I just use Pygame? Well, there's, again, too many hurdles. They had to know about a game loop. They had to know about your bounding rects and your collisions, and that's not the important stuff. The important stuff is to start thinking, the algorithmic thinking, not the syntax and not the internals of a particular engine. So this is where we just work in that more abstract concept of these are objects, these are how they work in the world, and it's all event driven. So there's a website for that. Everything that's on that website's being shared with you today anyway. so you don't have to rush and write down that URL. But it's game frame for Pygame. That's my dog Toby. It's exactly like it actually, just cartoon-wise. I thought it was a good logo for some reason. So you can go there, and we've got setup instructions for Windows, Mac, and Linux. We've got a full tutorial there called Veggie Samurai. Veggie Samurai is a window, it's a single room game, and all you do is you put vegetables on there and they start bouncing around the room, and you have to click on them to kill them. And then you add some bombs. If you click on the bomb, you lose the game. There's a whole bunch of stuff bouncing around, so you have to start being really accurate about where you click, and they seem to like that, and it gives them all the knowledge that they need to go ahead and actually write in game frame. We also have a bunch of example games. So once they finish Veggie Samurai, you've got an idea how it works. I've got about 6 example games that are all incomplete, but they all do something slightly different and teach them a different lesson. And generally for year 9, I give them the project of, you need to write a game. You can use these games as a base. You can pick one that's closest to what you want to do. You can pull features out of some of the others. So that transference knowledge of taking something and putting somewhere else, even if they didn't directly write it, they had to adapt it, they understand it. Year 10, they tend to write stuff more from scratch and build more complicated things. So just go back there. So I'm going to have to break away from this slide so I can show you some of this. I haven't seen any questions, so while I'm grabbing this, is there any questions? No? Not yet. Just move this over here, it's easier. Okay, so this is going to be what's in the shared folder anyway, so you guys will get all this. So we can start seeing some of the things. We've got game frame there, PyQt, and just while I've got this open, I'll just go into Turtle and show you. So we've got 5 to 6 weeks. We've got 5 weeks of lessons, and then there's a 6th week to consolidate. But if I go into any one of these folders here, you've got teacher files, student files, lesson plan. Teacher files, that's a video to play in a lesson. There's the actual lesson, worksheet, and these down here are videos for the teachers, so that they know how to teach it. If I go back to students, so students have a video getting started with IDLE, so that's writing their first program. There's a video there, there's a lesson worksheet, and the code files. So those code files are pretty much empty because we're at the start. They just fill out them, and I get them to hand in every week. Okay, so if I go back up, let's see if we can get to one of the game frame games. Not there. If I don't get it in, then I'm just going to pull from Git. Oh yeah, so everything's available on Git as well. It's all open source. Okay. War Aviator, here we go. So the layout of the code, I normally do it in PyCharm, but I'll just show you the raw code here, is we basically have a set of folders that we break things up to make it easier. So I'll just explain some of these. That game frame folder is all the code that I wrote. It's there, they can open it up, they can access it, they can look at it, they can look at the internals, see how it works, maybe they can extend it, maybe they can break something, that's fine. Break it, they can always just give you another version of it. We've got a sounds folder, so all the sounds go in there. Image folder, all the images go in there. The ones we really work out of are objects and rooms. So in there we'll have rooms as classes, so we might have 5, 6, 7 rooms. I've got one at the moment that's got like 32 rooms, they just went crazy. And then you've got objects and things that are in the room. So if you know GameMaker, anyone just put your hands who knows GameMaker? Okay, so you should probably recognise that layout. It's obviously going to look a little bit different, it's not down the side, but it's the same basic layout. This main controller, you don't edit this at all. It's really hard doing it. Okay, that'll do. So you don't edit this at all. This is just my little bit of magic using some reflection to figure out what the next room is and launch that. So they don't edit that, but that's the file that actually launches the entire program. When they run a game, you run that file. So if we go into the rooms and have a look, so this one's got a simple level 1. So what I'll do, just quickly, is I'll run that main file, and we'll just have a look at what comes up. Okay, so we've got this game here. It's got some sound. Has some enemies that randomly generate and come down screen. I run into one, lose a life. Okay. And once I've killed all the enemies, then that's the end of the game. So it's an incomplete game, it's just got one level. It doesn't have a start screen and end screen or anything like that. I've got another example game that has a start screen and end screen, but virtually no gameplay. So you can see that they start to build things together. There we go, so it just ended. So if we have a look in the room, let's have a look at what the room is. Okay, so the first few lines are just boilerplate. We included the things that we need. So from game frame, we need to have a level because this is what we're implementing. There's global objects. We'll look at that a little bit later. I might just pass you off to the videos. And we've got the different objects that we've made and we put them in the room. So we get this level. So we're going to call it level 1, whatever we want. It inherits from level, so it inherits all that code that I wrote. So it's got all the collision detection and everything else. And then this is really where it starts. So they've got their init function. They can set the background image. They can set it to scroll. So you can see it's just straight calls at this point. 4 pixels per frame. It's going to scroll down and repeat. So now we're going to add objects to the room. So add room object, and plane is something that we've made. I'll show you that in the other file in a minute. And we give it a location. So an X location, a Y location. The islands are going to be generated randomly. So we basically just build up our room. So they know whenever we create a room, that first function is building up and putting all the things in there. And then you pretty much just let it run. Because it's all event driven, all the objects in the room will just act appropriately, depending on what we did. Okay, so we've got an update score down the bottom that gets called if you need to update the score, and adding an enemy runs on a timer. So some of the things I put in there that were useful, I figured I needed a timer. So if they want timed events, they can just say self.setTimer 60 frames, so that's 2 seconds. So it's 30 frames every second by default. All of this stuff you can change, obviously. It's 800 by 600 by default, you can change that. And every 60 frames, we're going to add an enemy. So it's just going to call that add enemy function, which is itself. So it kind of creates a time loop. So there's some of the features I put in. So one of the toughest things with writing game frame was actually not what to put in, but what to leave out. So this is why when we have something that's directed at what we're trying to teach, what the curriculum or the syllabus that we're following, I really found some of the other tools were lacking. So if you had Game Maker or Godot or something, they don't have that one objective of must put the student first. They're also maybe selling a commercial product and they have to think about sales. They might also be having an audience that want to make commercial games. So they have to make it as best as they can to compete against other products, so it makes it really easy to make games. I don't care about the games. I really don't. It's a means to an end, it's a tool that gets the kids interested. I'm interested in what they learn to code. So there's certain features that other frameworks will have there. Oh, you just type this and bang, all this happens. I don't want that, because that's a particular area where I need them to learn. I want them to learn to iterate over a list of enemies and pick something up. I don't want to just say, give me the enemy that has this or something like that. So a lot of thought really did go into what to leave out and what to put in, with the aim of always knowing that yes, I want them to have fun. A game is a way of doing that, but ultimately it's the code that I want them to learn and get through. Okay, so there's tons of stuff on Capture the Flag. I've got some videos. Again, I've got that tutorial which will be on here. So hopefully that sort of overview just is enough to get you going, and then the workshop, when we get some stuff on your machines, maybe we can have a deeper look at it. Any questions on that before I move on to my query tree? No? Any general thoughts? No? Haven't wasted your time.
So you're moving on to my query too today. So I'm just sort of thinking in your head, unit 1, what sort of thing are you going to get them to develop? Because you've
Yeah, right, okay. So actually that's a really good point. Thank you for bringing that up. So this 5-step series, I really ultimately long-term planned it from 9 through to the end of year 12. I ran this for year 12 this year, top to bottom.
Yeah.
So you can do that if you want to use GameFrame. I'm actually not going to use GameFrame in senior. That's going to be a junior tool for me. So this year, because I had to, they didn't have the base knowledge. Poor kids, I pushed them so hard. They went through this whole thing here, ended up writing a desktop application a few weeks ago and submitting it. And they did a really good job. A lot of them did some fantastic work. So yes, if you want to use GameFrame, you want to do gaming in year 11, year 12, you absolutely can. I'm not, that's going to be junior school, this is going to be senior. So in answer to your question, Unit 1 and 2, we're talking basically databases and programming. So it's going to be...
Are you swapping them around?
Probably not, I might have to flip that back around. So this is the ultimate, but it doesn't really fit. So what I'd do is I'd do that part for Unit 1, not the SQL, not the SQLite. So just build a desktop application that does something, that doesn't talk to a database.
Yeah.
Unit 2, we do all the database stuff. Unit 3, we come back down to this one. But because there's discrete tools, I just put them in that order. So then we'd come back down here, we would have learned to do a basic desktop application. We would have done all our database stuff, and then we move on to doing the database-driven desktop application. Now, as I said, I did think of this holistically over a long period, rather than having a patchwork of little tools that do the different things, and that's okay, but I really wasn't comfortable with it. Each one feeds into the next. You can see there's a natural feed from Turtle into GameFrame, from GameFrame into Capture the Flag. Capture the Flag is actually written in GameFrame, so it's an environment they should be familiar with, but they just program the bots only and only think of the algorithms, not the rest of the game. My Query Tutor, which we're going to have a look at the moment, this is a desktop application with a series of questions, and they step through each of the questions, and they get immediate feedback. That's a green result, so that's correct. They can look at the data they should get versus the data they actually get. They can look at their progress, all that sort of stuff. When we finish with that, we go on to here, you might think, okay, My Query Tutor's done. Well, it's not, because remember the tools are open source. So this year when I actually ran this, we did My Query Tutor, we did some desktop stuff, and then I went, well, okay, we now need to build a desktop application that talks to a database. We have a model here. It's a desktop application that talks to a database and it's open source. We use this as an end user. Let's unwrap it and have a look at source code. So that feeds straight into that. They've got a real life example of an application. They can go in there and say, well, how does that connect to the database? Wow, that's really easy. It's only 2 lines. Because there's an SQLite driver built into Python. You just tell it which file it is, you open it up and away you go. So they can use all the source code for there as a real life example of what they should build. And then of course they adapt it to whatever the application is that they're actually building. But all the technology, all the examples are already there in this application. They've just now got to transfer that knowledge. So that transference of knowledge proves that they do actually understand the code and they know what they're doing. Because they have to apply it in a different domain.
So an example of that might be you give them a very large database file and say, now we need that application adapted to work with that file. Is that a new application?
Yeah, possibly. So what I did this year is I had 2 separate sections. One, they had to build the database itself, and they could get data from somewhere else and import it. Most of them actually generated data, put it directly into the SQLite file, and we used DB Browser, which is a Qt desktop application written in Python that talks to a database and it's open source. But they use that just to go straight in. It's like a PHP MyAdmin type thing where you can use a GUI to actually do all the SQL stuff. But we always kept going back to the text. Okay, yes, we can go here and quickly put data in, but what is the actual insert statement? So I also made them write scripts that built the database. So that SQL scripts they could import. And once they built that up, that was the first assignment. Great, we've done an ERD and we've got our normalization and we've built the tables and we've got it all working. Now, you're going to build a desktop application for that database. So yeah, you could either supply the SQLite file, say here's your SQLite file, now I want you to interrogate it and have an interface that can add to it, modify it, all the CRUD stuff, create, read, update, delete, or you can build, they can build it themselves. I got them to build it themselves. Now, if you, just on this topic, there might be a few of you sitting there going, well, have I wasted my time coming here because I'm not going to do a desktop application for year 11 and 12. Okay, there are other options. As I said, you can just take bits and pieces out. Maybe your route might be go down to about here, maybe even this. Oh yeah, probably that, definitely that. And leave off this last one and move to, what were you saying before, Daniel? You're looking at Flask or Django, one of the web frameworks for Python, because you haven't wasted anything. All this stuff is still going to be directly applicable. Now, if you want to go to a LAMP, a PHP or something like that, well, it's not as directly applicable, but it's still very much applicable. Like you've still got all the same concepts, you just got to change your syntax a little bit. So if you can use that much of it, it just changes a bit, because I think that's going to be applicable for everyone. And I think most of that could be used, but it's completely up to you. Take the bits that are useful for you, leave the bits that aren't, or take the whole lot. Completely up to you. The power's in your hands. Okay. Any other questions? Nope. Okay, so now I'm going to see if I can find a way. That up. Geez, the live demos are not going too bad today. It's unusual. Okay. So this is an old version of my Query Shooter. Again, later if I get time, I'll show you the new updated version, because it's much, much better. It's much more visually appealing and interactive, but this was just get it out the door because I needed it for year 12 this year. And I didn't implement all the things I would have liked to begin with. So, okay, basically you get this application, and I'll just show you some stuff. We've got different topics up here, and we've got different questions inside those topics. Oh, this is the new one.
Nice. For the first 2 or 3 maybe.
Okay. So the idea we had to begin with is we wanted to make, among other things, we wanted to make it interesting for the kids to learn SQL. After talking to a lot of IT teachers, the one thing they kept saying was SQL is boring and it's really hard to get kids to learn. So what the idea we had, and we didn't have this for version 1, because as I said, we have to get it out the door, but what we're working on at the moment, when I say we, Kesh and Pete are now part of the community, the development community, and they're actually actively working on this now with me. So I didn't do any of this stuff. I like text, code, not pretty animation stuff. That confuses me and upsets me. Okay, so we've got this and we want to make it interesting. So we had this idea, it came up in one of our meetings last year, that maybe we should have something like a detective solving a crime. And you work out little bits of information. So somebody fled the scene and they had size 9 shoes. Okay, find everyone in the database who has size 9 shoes. Okay, we've broken it down now to a list of suspects. And then in the next section, we need to do a slightly more difficult query to nail it down there. And then right at the end, we do some god-awful massive join thing that gives them the final answer. So they build up the skills getting there. So most of these questions aren't there yet. It is a work in progress. So it is in development, but completely usable. Version 1, I did use it for year 12 this year, and it seemed to work very successfully. So you can go in there, and I'll just give you a quick look. So if I click on the select and as, and I go to the first question, mission briefing. Do you wish to accept this mission? Okay, let me click on it. Okay, write a query that will return all the attributes of information from the continent table. To write this query, you must reveal the following top secret documents below. Okay, so down here, we start to get a little bit of information about what we actually want to do. So Pete put a lot of work into this. So I brought the code, he brought the pedagogy, and he wanted to approach it as an I do, we do, you do progression. So to begin with, I give you everything you need. So I've done the problem, just type it in. If you can follow the instructions, you can get the answer. Then we're given an example. So here's a query that pretty much works, but there's something wrong with it. Can you fix that up? And then they fix that up. And then finally, we need a query that does this. And they have to go and do it themselves. So progressive hand-holding to push them off the... So that's how it's probably not a good analogy. But, so they walk through this. Okay, so let's have a look at it. We go down here. We want to write the query. says, okay, we want to use the select keyword. Select. Okay, have I finished? Let's see, let's run. Okay, no. It's incomplete, it says up there, try again. But you got a green here, select was right. We got something right. We got a green there. Okay, I might just put that to the side for a second and say, okay, well I didn't get it, but I don't really understand what was I supposed to get. So I'll have a look at what the expected data is. So I can now have a look at this and say, well, for this question,